Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady.
And Levi.
And Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes. All raps have one rhyme.
We'll see you on 2 West.
Yes. 2 West.
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because
disgusting gray moths.
Yes, those gray moths that you hear, they're like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all.
Haha! Oh, hold on. This should be on. There we go. Didn't have the browser on. Sorry about that, everyone. Our stream just probably looked a little naked. And I'm sorry if that was a little unsettling. Jerklump! Jerklump! Plump to the jerk.
Jerk. Hair.
Did Jerklump respond to our message?
Yes. Hold on. I think
with all my heart. You remember that from Dragon Tales? I wish with all my heart.
To go some to a land of fart.
Oh, is that what it is?
Something, yeah. Because they traveled here.
I think it's just like that.
Jerklump has not responded yet.
Okay. Oh,
It's
you
okay.
just saw. I just saw.
There we go. Very good. Tell me something, Jerklump.
Jerklump, you got questions for us? And you see, Pi just commented just now. Pi, are you watching right now?
That's AM. Let's try.
Psych.
Nor is it 8:05 right now, or 8:03.
Oh.
There are several things wrong with your assumption.
So much
that
wrong.
I just responded.
Hey, Jerklump. Let's do some questions, yeah? What you got for us? Where would you like us to begin? Also, this looks nicer now. I like it.
Thank you.
You're welcome.
Your P is not the best.
This is true.
Hey, I don't mind. Thank you, Jerklump.
Thank you. Okay, let us do some Reddit stuff. Oh wait, no, we got something general in the ACT. That's from a long time ago. How did that not ever show up before? Oh, we got a Jerklump question. Yeah, baby. Let's do it. Alright, Brad, this looks fun.
Can I do
As
it?
jerk lump questions always are.
I would like to do it.
You want? Oh wait, we don't have to do that anymore.
I love
Wow,
that.
that's very exciting.
Isn't that nice?
Yeah.
Okay. A finite arithmetic sequence has 7 terms, and the first term is 3/4. What is the difference between the mean and the median of the 7 terms? Well, whenever we have just 7 terms, or just a, it's a small number of terms. I draw little slots just to keep track of what we know. 3, 4, 5, 6, 7. There's 7 terms. It's an arithmetic sequence, which means we're adding something every single time. All right, so the first term is 3/4. The problem is we don't know what we're adding by every single time. So there's 2 ways around that. We can either just insert a variable and see what happens with that variable, or we can just choose our own common difference. The common difference is what you're adding by each time. Because if apparently this should be doable without, hi, how do you resolve math problems? That's a very large question. I'm not sure what you mean by that. Resolve math problems, resolve math problems, like math problems in general, depends on what the math problem is. Papel, you're gonna have to be a little more specific about that. You can sign up for our Discord down below, and you can send us pictures, and we'll pull them up and we'll solve them. If that's what you mean by that, maybe. So let's just say that our common difference is 1. We're adding 1 every single time. All right. If that's the case, that's 0.75, 1.75, 2.75, 3.75, 4.75, 5.75, 6.75. That's an arithmetic sequence with first term 3/4. What is the difference between the mean and the median of the 7 terms? Well, the median is going to be pretty easy because they're already in order. This right here is the median, 3.75. So we just need to find the mean. And I'll tell you what's gonna happen right now. The mean is also going to be 3.75. You can do it on your calculator. Add them all up, divide by 7. You will get that 3.75 is also the mean, which means the difference between them is 0 because they are the same number. Now, how did that happen? Here's why. Every time you're moving up, you're going up 1 or down 1. This list is symmetrical, which means that 2.75 and 4.75 are equally distant away from the middle of 3.75. So every time you take the average, it's like a low term cancels out with a high term to be the average term in the middle. You know, if you have 8, 9, and 10, and you say, what's the average? They're clustered symmetrically around 9, so they're going to end up giving you that middle number 9. So your mean will always be whatever this middle number is in the middle of the arithmetic sequence, which will also be your median. The other way you could have figured this out is if you had just left d as the variable d, you would have, 3/4 plus d, 3/4 plus 2d, 3/4 plus 3d, that's your median, 3 plus 40, 3/4 plus 5d, 3/4 plus 60, that's a tongue twister. If you were, so just to recap, this middle term would be 3/4 plus d, 2d, 3, plus 3d. And then if you do your average with all of these d terms, you'll eventually get 3/4 plus 3d again. So you can just use d, or what I would recommend, which is faster, is put your own value in for d. Put 1 in. That's a pretty nice one. Yeah. So that's kind of fun. I like that. Hopefully that makes sense. Let's get out of here now.
Anything else?
Jerkwum says okay. Well, Papel, we're still waiting on. How do you resolve math problems? It's such a large question. Is there a specific math problem you'd like us to resolve? Or how does one go about solving a math problem in general? Oh, Jerkwump, we got another one. You want to do this one?
Mm-hmm.
Oh, Jerklump's starting to just dish them out.
That's what I'd like to see, Jerk Lump. Thank you. We're eating well tonight, Brady. That's what we're doing.
We're dining with the gods tonight.
Yes. The god Jerk Lump.
Have fun with this one.
What a god he is. Oh my gosh. The 3 parabolas graphed in the standard xy coordinate plane below are from a family of parabolas.
Oh, that's so nice.
So they're all brothers and sisters, most likely.
Hopefully they sent us a Christmas card this
Oh,
holidays.
yeah, we sent one last year, but I'm not sure it went through. So I feel bad. All right, so a general equation that defines this family, or the parent function, contains the variable n in addition to x and y. Whoa, that's exciting. For one of the parabolas shown, n equals 1. For another, n equals 2. And for the third, n equals 3. Which of the following could be a general equation that defines this family of parabolas for all n is greater than or equal to 1? All right. First mistake you made, Jerk Lump. You circled 2 answers. If you circle 2 answers, you will be marked wrong. Understand? Good. You circled n to the x squared plus 1, or 1 over n. Sorry, I said n to the x squared, not n to the x squared. N times x squared. You're definitely on the right track. I want you to graph these. Let's just, let's graph and really only focus on the first 2 quadrants. And it looks like we're doing x squared plus 1. It seems like you figured that out. Let me know if the other pieces of C, D, and E don't make sense to you, in that you're not sure exactly what each of those different translations will do to the graph visually. But you're right. We do add 1 at the end because our vertex moves up 1. So we do have this point on all the graphs. And now let's just plug in. Okay? Let's look at A. Let's say that we have y equals something x squared plus 1. So let's say that this is 1. Let's just say n equals 1. Okay? Even for answer choice B, the same thing would happen because you have 1 over 1. So you just get x squared plus 1. This is essentially your parent function for this case. So let's plug in values. When x is 1, what is y? Y would be 1 squared plus 1, which is 2. Okay, easy enough. And then what if x is 2? Well, 2 squared plus 1 is 5. So now we are up... Is that mine? No. Okay. So now we're up to 5. And then if we have 3, 3 squared plus 1 is 10. So now we're up to here, okay? And this is a parabola. It will look like this. I assume you know that, okay? This is our parabola when n equals 1, right? Now I'm going to do another color. Let's say yellow. Let's say we have y equals 2x squared plus 1. So n equals 1. Let's do the same thing. If we plug in 0 just like before, we get this is all 0 plus 1. So we get the same vertex there. So that's easy. And then let's plug in 1 now. If x is 1, we get 1 squared, which is 1, times 2, which is 2, plus 1, which is 3. So now we're up here. We have this point 1, 3. If we plug in 2, we have 2 squared, which is 4, times 2, which is 8, plus 1 is 9. So 2, 9. We've already jumped up here. If we plug in 3, we get 9 times 2 is 18, plus 1 is 19. So you're going all the way up here. So now our function looks something like that. Okay? It gets narrower. I'm not sure how you learned it, or maybe you didn't learn it at all, but there's narrower, there's, some people say stretched. It depends on what you learn in high school. Mish Mish, what's up? Yeah, we have to do other weekend things. Weekends are when we tutor privately, mainly, and also do personal things like, Brady, what are personal things we do? We go to the park.
We make personal pizzas.
We make personal pies. Yeah. Better deal than individual slices. So we narrowed. We got narrower. We got stretched vertically. Doesn't really matter how you say it, because if you think about it, you're doing your function of x, and you will move up 1, but you're also going to multiply your result by a lot. So your value, whatever x you have, your y value would just get bigger way faster. So you just go like that. Yeah, so you learned this, Jerk Lump, and that's fine, and now you've forgotten it, and now you're relearning it, or it's more remembering it. It's more that. So this is n equals 2. This is n equals 1. So the answer here would clearly be A. What B is saying is actually the opposite. If you are multiplying this by a fraction, it means you plug in an x value, you do stuff to it, and now you're multiplying by 1/2 or 1/10 or something. So your y value is going to be decreased, right? Because you're multiplying it by a fraction that is less than 1. So something like that, let's say if we have y, oh, you can't see that, can you? Y equals 1/10 x squared plus 1. If you plug in 0, you're going to get the same thing. Are these all recorded? Can I rewatch these? Yes, Mishmish, you absolutely can. Now, that being said, it's hard to keep track of, and there's a lot of stuff going on, but you can scrub through and see what you want to watch for sure. Yeah, if you see any problems that are good to watch. Also, Mishmish, if you want, you can put in some questions now. We can do them as we go, and then, yeah, we haven't been on for that long. We'll do your questions even if you're not necessarily watching, and then you can watch them later. Now, we're not going to prioritize those questions if other people are watching live, but we can do some of yours even if you can't watch them. So I can skim to the part. Yeah. Oh, I see. Gotcha. So here, if we plug in 0, we're going to get the same exact vertex. It's still going to be at that 0, 1. But now let's plug in 1. Or let's plug in 2 for good measure. We plug in 2 for x. We get 2 squared, which is 4, times 1/10, which is 4/10, plus 1, which is 1 4/10. So we're not even halfway to 2 when we plug in 2. So we're out here, and then we're going to keep on going like that. So this is when n equals 1/10. What? There you go. What this should show you is that leading coefficient for parabolas, if its magnitude is greater than 1, you're going to be stretched vertically, you're going to get narrower. Basically, think of it as your y value jumping up way faster because you're multiplying by a number that is greater than 1. If you have a fraction out front, you're going to get wider, you're going to be stretched horizontally, you're going to be smushed vertically, whatever you want to say, but your y values don't increase as quickly. Okay? The plus 1 moves the whole thing up 1. All right. Let's have Brady do another jerk lump question. Is that what we're doing here?
I would like that.
It is a jerk lump night tonight. Oh, there's only 2. Okay, so nothing crazy. Here, let me get
jerk lump night tonight.
Okay.
I guess it's jerk lump
is this?
night.
I like this question. This is a good one. Oh, I don't need to do. I'm so used to doing that.
Neo-Socratic.
Neo-Socratic, hello.
Neo-Socratic.
Did you send a message to Neo-Socratic?
I did.
Oh, that's probably why. Yes, so it is just A. Yes.
Excellent. Well, I'm going to tell you about. Do you say Mario or Mario?
Depends on the spelling. Is it
that-
spelled with an A or a?
I have. Not,
Are you mad at me?
No, I mean it just kind of.
Do you like me?
I just let it slide off me.
Oh, let it slough off you.
Slough. SLOUGHF. Slough. By the way, the word was predicament. That's what that was.
Oh, predicament.
55. Mario was riding a bicycle with wheels 26 inches in diameter. During 1 minute of Mario's ride, the wheels made exactly 200 revolutions. At which average speed, in feet per second, was Mario riding during that minute? Excellent. Hello, Hono.
Oh no.
Hello. Neo-Socratic says, hello, Hono, how are you? Neo-Socratic says, do y'all have any experience with transfer admissions and whether or not retaking the ACT, SAT for my trans application will be worthwhile? I have no experience with that. Levi, do you have any experience with that?
No, do you?
Yeah, I do actually. I'm glad you asked. Yeah, Neo-Socratic, you're gonna have to look that up. We're unknowledgeable in that department, and we're not gonna lie. So, Jerk Lump drew a wheel here. Always a good start. The wheel is 26 inches in diameter. So considering that you can find the area and the circumference of a circle, and they give us the diameter, it's probably going to be one of those things. It's going to be the circumference that we care about. Because, here's the important part. The circumference of a circle if it is a wheel on the ground, will cover a distance that is equal to its circumference over the course of one revolution. What do I mean by that? Great question. All right. Here's what I mean. So the wheel is rotating, but it's in contact with the ground all the time. There's no slippage. It's just fully rotating, touching the ground. So this point on the tire, probably going to touch down right here. And then let's say this point on the tire, probably going to touch down right here. I'm going to draw this out. And then this part on the tire, probably over here. And then by the time you get back to the bottom, you have rotated one full revolution. And so the distance that we've gone is one circumference. I'm going to draw some dotted lines here. It's going to make it fun. So dotted line. There we go. You see that's where they're going to touch when this thing rolls. So the circumference of this wheel, 2 pi r, or pi times diameter, is going to be 26 pi. And it says 26 pi inches in diameter. Okay. 1 minute of his ride, it made exactly 200 revolutions. The distance it will have gone is 200 times the circumference. Every revolution brings him one circumference length forward. So it's going to be 200. So this is what, okay, revolutions per 1 minute times, for every 1 revolution, that's 26 pi inches. All right? So the revolutions will cancel out. This will give us how many inches per minute he's going. But what they want is feet per second. So we're going to have to do a little bit more converting. We want to get rid of inches. So we want to put inches on the bottom and feet on top. The last thing we want to do is turn minutes into seconds. So because minutes is currently on the bottom, we're going to put, minute on top and seconds on the bottom. So if you look at the units that will still last, we have only feet on the top and only seconds on the bottom, which is feet per second. So now all we have to do is multiply across and simplify. So this is going to be slightly fun, probably. Let's see what we can do with our simplification. So 260, they both have a 0. I'm going to take that out. 26 and 12, those are both even. I'm going to take a 2 out of both of them. So this becomes 13. Keep in mind the pi is still there. I'm just going to write it up here. And this is going to become 6. All right. 20 is even, as is 6, but I'm going to turn this into a 10. I'm going to turn this into a 3. And, oh, look at this. 10 and 6 are still even. I probably could have simplified them both at the same time. This is now a 5, and this is now a 3. So where we're at here, if we multiply across, 5 times 13 pi, which is going to be 50 plus, so that's going to be 65 pi over 9. 65 pi over 9, which is the answer. That's A. Oh, I for some reason thought I was going to have to do decimals here, and I was going to have to get a calculator. But 65 pi over 9, yeah, is going to be feet per second. Okay? The big hurdling block here is that a circumference is going to be the distance you travel as your wheel rotates one full revolution, or one rotation, things like that. Cool. Yeah, Jerklump, what do you think about that? Does this just drive you crazy? I know it drives me crazy. Crazy with math. So you know what kind of math this is, Levi?
No, my lord.
This is that good stuff. This is crystal math.
Oh my gosh.
Sorry. Just trying to remember basics. Yeah. There's a lot of moving parts here, so to speak. No pun intended. It's a wheel. A lot of fundamentals you gotta kind of group together in order for this to work, because it's like not just geometry, but also rates and also unit conversion, and conceptual understanding the connection between the circumference and the distance you're traveling if you're a wheel, That's rolling. Rolling, rolling, rolling. Rolling, rolling, rolling. Ba-ba-da-dum. Rolling. Okay, any particular part of this jerk lump you'd like me to talk about or do in more detail, more depth? Or maybe less depth? Let me just kind of glaze over it, not really go in detail. You let me know. Let's see, do we have more questions? Oh, Levi.
We have more questions?
Yeah. Jerk lump's gone. Okay, good. Very good, jerk lump. I'm going to rotate this because that's something we can do now. Tell me something good. Oh, runner Billy Mills. I love this one. He's great. Are you happy in this world?
I love the English questions.
Jerk lump, no problem. You're taking advantage of this, as you should. I'm guessing it's 15 because that's the one that is circled. Is that one that you have an answer on? Probably.
Oh yeah, yeah. You gotta cut those math questions. Gotta cut those crystal math questions with some English, huh? Toss a little English on there, huh?
Yeah, exactly. Then you can make it cheaper.
Exactly.
It's not as
To
pure.
make, but not to sell.
Right.
Right. That's
Oh,
how
of
you make a
course.
profit.
You know,
We're teaching you math and life skills.
apparently Moses was a prophet.
Yeah?
I think so.
That's awesome.
I don't know how to ask questions in the ring section though. Well, I mean, is it like specific questions like, oh, on this passage, why is it this answer, or is it just general reading strategies? You could.
Yeah. Question types that you find difficult, we can go through them and talk about ideal approaches. Specific question, yeah. If you have the link to the test itself, we can do that. If it's one of the main 10 tests that's out there, we can pull those up ourselves. Okay, I'm going to make this a tad bigger. Okay, we are doing number 15. Did Jerklump say 15? Jerklump did not say necessarily.
I assume that's the one that's circled.
Okay, we're going to do number 15. 15, cool. Okay, so just looking at the answer choices, we have but, sometimes, sorry, what am I saying? But, nonetheless, in fact, and delete. So I'm going to write these up here. But, that's not what it is. No, never, none, none. So, identify the question type first, nonetheless, in fact, that's 2 words, and delete. So those are our 4 options. This is clearly this is not a word choice question exactly. It's definitely not punctuation. This is transition. So yes, you're choosing the words, but you need to figure out the transition. Do not pay attention to the answers, okay? 3 of these are wrong, so they're going to mislead you more likely than not. So don't rely on the answers for this question, okay? Rely on your understanding of the context. Transition words are used to transition, of course, between 2 ideas, right? If we identify the 2 ideas and then figure out their relationship to each other on our own without being influenced by these, we have a better shot at not making a mistake. Okay, which means we have the first idea, and then we have our transition word, and then we have the second idea. In this, we have runner Billy Mills qualified to run in the 10,000 meter race in the 1964 Tokyo Olympics. Sure. So this guy, Billy, qualified for the Tokyo Olympics in the 10K. Awesome. Second idea, do not say in your head when you're reading these ideas the word that's there. Don't say it because it's going to mislead you. We have the first, he's in the 1964 Olympics in the 10K, great, in Tokyo. He was a long shot. Ah, okay. He was a long shot. So he made the Olympics something, he was a long shot. Those 2 things do not agree. Now, they're not contradicting each other, but there's some contrast there. He qualifies, he was a long shot. Now, maybe idiomatically you're not comfortable with the term long shot, but if something is a long shot, it means you don't have a great chance at it happening. So I see these things, we have a positive and then we have a negative. That shows me contrast. So I like but, nonetheless, is sort of related to contrast. Let's leave that. I don't like in fact, because in fact, that's when you're trying to go further from the first idea, right? I like chocolate. In fact, it's my favorite food. There's no contrast there. I like chocolate. Now we're going further. Hey, Usfo, how are you? Hello, streamer. I have a name. However, no idea what you're saying. Nevertheless. So I don't like in fact. Delete. Maybe, but I think we do want some sort of relationship between these two ideas. I think that is important. Now, I like but the most. Nonetheless, means that we are disregarding the first thing, okay? In this case, we're not disregarding the first thing because we do need to know and we do care that he's in the Olympics, but he's a long shot. So I like but, I think that's the right answer here. Nonetheless, is disregarding it, that's not quite right. That's basically in spite of. Oh, long shot, you didn't know what that meant. Yeah. You were saying contrasty words. Just watch your language there, Usfo, okay? Delete here doesn't work super well. Also, actually, now that I'm looking at this more, this could be interpreted as a punctuation question because we have two independent clauses. We have runner Billy Mills qualified for whatever, so we have our subject, we have our verb, it's an independent clause, and then we have he was a long shot. That's two independent clauses. You cannot separate two independent clauses with anything aside from a period, semicolon, colon, or comma fanboys. A is the only comma fanboys here, so that's the only correct answer, even grammatically. So grammatically and contextually, A is the right answer. Okay, let us do more. Oh, that's all we got. Hey, Usfo, you're here for the first time today, so what you got for us? I'm going to rotate this back 90 degrees. How do you rotate this again, Bird?
You go down to Window Display.
Transform.
Yes.
Clockwise. Yes. Mm-hmm. Oh, Bird.
What?
We need a word of the day.
Oh, I got one.
Yeah?
Unless you have one. I got a good one.
Yeah, why don't you come up and do your good one? I don't have one off the top of my head.
Okay.
But while he's doing this, before anything, you must promise us that you're going to ask us more questions. Hono asked a question. Awesome.
The word of the day is homunculus, as in Levi. Explain to me, what's a homunculus?
It's
It's a tiny little man.
yeah, it's the Homo sapien that is inside of the binoculars that focuses it for you.
Yeah, that makes sense.
Word of the day. There we go.
I'm gonna get a real definition. I do love me some good homunculus. A homunculus. Homunculus is a very small human or humanoid creature.
Oh, you weren't kidding.
Yeah.
Oh.
A supposed microscopic but fully formed human being from which a fetus was formerly believed to develop. Well, that's not exactly how it's used anymore. Yes, a representation of a small human being. Ah, like a tiny person. Like you, Levi.
Very like me.
Yes, it will like you. Am I doing this one?
Do you want to?
I think I like that, yes.
Do you know what to do, Brady?
I think so.
You must subtract and then simplify.
You think
Careful,
I can't?
Clarice.
You think I can't do that? Just watch me.
Oh, I'm gonna watch. Actually, I'm not. I'm gonna eat.
Subtract and simplify. Will it be that order? Can I subtract first and then simplify? Absolutely not. Why? Because these don't have the same denominator. You cannot add or subtract fractions if they don't have the same denominator. The first thing you must do is give them the same denominator. Now, we also are going to have to simplify. So why don't I just, well, here's what you want to do. You want to factor first. We don't want to think about giving them the same denominator yet because we want to see what kind of denominators we're truly working with. So we need to factor both of these fractions. So we have 4y over y squared minus 2y minus 15. If we want to factor that, that means that we're looking for two numbers that multiply to negative 15 and add to negative 2. Those numbers are negative 5 and 3. Negative 5 and 3. So this is going to be y minus 5, y plus 3. We will continue now. Minus 3y over. They must multiply to negative 6 and add to 1. 3 and negative 2. So we have y plus 3, y minus 2. All right. Now notice that they have part of their denominators in common. They both have y plus 3. The goal is to make the denominators the same by multiplying both of them by something so that they match. We don't need to multiply either of them by y plus 3 though, because that is a component that they both already have. What does this have that this does not have? This right here, y minus 2. If we want this to look like this, we definitely need to give this a y minus 2. So we will do that. Remember to multiply on the top and bottom. Otherwise, you're changing the value of the fraction. You don't want to do that. Multiply by the top and bottom doesn't actually change the value of the fraction. With this, we're missing something that this one has, which is y minus 5. So if I multiply this by y minus 5 on the top and bottom, suddenly we have two fractions with the same denominator. So now we can actually subtract. So here we go. I'm going to multiply these up here. What's that going to give me? 4y squared minus 8y. And that's over this long denominator. So we have y minus 2, y minus 5, y plus 3. And we are subtracting, I'm just going to use it all as the same one. We're subtracting 3y times y minus 5. All right? We're subtracting that. So everything on top of this fraction is what we're subtracting. Now we want to multiply these together. So it's going to be minus 3y squared plus 15y. Do not forget that this negative will apply to this term as well, making it positive. So minus 3y squared. And then plus 15y. All right, we're closing in on where we want to be. So let's simplify. 4y squared minus 3y squared will just give us y squared. Minus 8y plus 15.
Why squared, my lord?
Of course. Minus 8y plus 15y is going to give us plus 7y. And this is over y minus 2, y minus 5, y plus 3. And if I'm not mistaken, there's not much more you can do. You could pull a y out of the top and get y plus 7, but that's not going to cancel out with anything on the bottom. So unless I did something wrong, this is where it ends. Let's just make sure real quick. Minus 5 plus 3, negative 15 minus 2. Good. Plus 3, negative 2 adds to 1, multiplies to negative 6. Good. We have to multiply this by y minus 5. Y minus 5, we have to multiply this by y minus 2. Y minus 2. 4y squared minus 8y. 3y squared plus 15y. I realize that the biggest mistake of adding a random x to one of the factors. Oh no! That is the biggest mistake. It does not get larger than that mistake. And if Levi and I didn't care for you so much, we'd be disappointed. But we're not.
We're not disappointed, Hono.
We're just angry. We're just very, very angry. You have flustered us beyond all recognition of Plus duration. Y squared, negative 8 plus 15. 15 minus 8 is 7y. Yes. That's all we can do with this. Be gone, problem. Hope you liked it. Total true love, Brady. Yeah, that's right. That's the face I make after I do math. Some good crystal math. Oh, there's another one by Klump.
Is it my turn, my lord?
Would you like it to be?
Yes, my lord.
Very good.
I like my new computer very much, my lord.
Is that so?
I do think, yes.
Why don't you marry it?
Because it is a computer and I am but a man.
But a man. Does that mean you are not good enough for the computer?
Perhaps, my lord. Perhaps.
Ah.
Is this your marker?
Yes. Ooh, ooh, ah, ooh, 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 ooh. You have a child's night at 9.
Yes, do you?
As do I. You have a child's night at 10.
No. Do you?
I do.
It's because all your children are in Chicago. Well, not all of them, but you have many.
Yes.
I have not many. Okay. Wait, is this the new one that you haven't done yet?
I just put it up.
Whose is this?
For you.
Jerklump, though?
I think so.
Okay. Jerklump, is this you? I'm going to start talking anyway. A restaurant occupying the top floor of a skyscraper rotates as diners enjoy the view. Wow, that's exciting. Ling and Sarah notice they began their meal at 7 p.m. looking north. Oh, okay. So at 7 p.m., they're looking north. At 7:45, they had rotated 180 degrees to a view that was due south. At this rate, how many degrees will the restaurant rotate in 1 hour? Okay. A couple ways you can do this. We're going to do a couple. There are some, in my opinion, faster ways, but they require an understanding of this problem that's pretty deep if you want to make sure that you're not making a mistake by doing it this way. And then there are ways that require a more, I think, a more important understanding, but they're slightly slower. So, always draw pictures if there's anything visual that you can figure out. So let's say we're looking top down at this restaurant. So they're looking here at 7 p.m., right? And then 45 minutes later, they go 180 degrees in 45 minutes. And now they're facing south. How long will this rotate in 1 hour? Well, we can look at it a couple different ways. We say, all right, well, to get 1 hour, we just went halfway in 45 minutes. To get 1 hour done, we have to add 15 minutes. So I'll do this in pink. We have to add 15 minutes and then figure out what that is. A couple ways to do this. We can just say, well, adding 15 minutes means we're adding 1/3 of the 45, right? Because this 15 minutes equals 1/3 of the original 45 minutes. We're adding, that's not, well, actually, no, it's not. Minutes, like that. Shh! I'm teaching math!
Sorry.
Yeah, I have to start over. I wanted to see another approach. Okay, got it. Did you do it this way by doing the, sorry, I don't know how long it took me to see that, jerk lump. Did you do it this way by saying, okay, this is 1/3 of 45 minutes, so 1/3 of 180 is going to be 60, so we're going to add another 60 minutes here. Sorry, 60 degrees, and puts us at 240 in 1 hour. Is that how you did it? You did it like that. Great. Okay, that's totally fine. We can also do it this way. Let's say we know that 45 minutes equals 180 degrees. Well, this is like, you know, if you can slice 3 apples in a minute, how many apples can you slice in 2 minutes, right? It's a proportion.
3, my lord.
Very much so. So now in 1 hour, so let's say 60 minutes here, we make a proportion like this. 45 minutes over 60 minutes equals 180 degrees over, let's say, theta. And then you can cross multiply. You don't have to. You can do it other ways. But you solve for theta here, and you also get 240 degrees. Does that approach make sense? I think I love drawing pictures. It helps a lot with your understanding. It's not as mathematical. It's more logical and visual. I like that way. I think always drawing a picture is a good idea. But this, I think, is the more, yes, this is a faster approach, and it's about, what am I saying? Not a proposition. Perception is not the right word. Proportion is what I said like 2 minutes ago. Anyway, so 240 degrees. Do you have any other questions? I'm trying to think, is there another way to do this? Not so much. Well, you could do this, okay, last way. You could say, well, we're doing 60 minutes, right? And we can do it the way that Brady did that last question. You sent another question. Okay, we'll get to that in a sec. 60 minutes, and now we're going to use a rate, okay? We're going to use a conversion factor. So we want to get from minutes to the number of degrees gone in that minute, right? So we're going to multiply it by the conversion factor of 180 degrees, because we have 180 degrees every 45 minutes. So if you do it this way, with unit conversion, our minutes cancel, and you get 60 times 180 divided by 45, and that will give you 240, and then you only have the degrees left, so it's 240 degrees. There are a bunch of ways to do this one. I like all of these. You want to do the next one, Bird?
Yes.
Okay. Or I can also, whatever you're into.
Whatever I'm into.
Yes.
What are you into?
I'm into tutoring. What are you into?
In tutoring?
I am in tutoring, yes.
Right now?
I'm into Turing. Turing.
You're into Alan Turing?
Alan Turing, yes.
Didn't he invent the computer during World War II as a way to solve the break the German Enigma code?
Yes.
It's pretty cool. It just seems like the best things we invent are during war, you know?
Seems kind of ideal.
Yeah.
This is fun.
Isn't it?
All right, Bird, you're up. I'm going to draw this for you, by the way.
Oh, thank you.
Yes.
That's very nice of you. All right, what do we got? What do we have? What is this? What haveth us? Jerklump just asked a question. Did you already answer that? Oh, it's this one here. The figure below shows quadrilateral ABCD. What is the measure of C? And you're asking, it was just doing either way to have you remember it. Oh, no, there's not. Yeah, quadrilaterals add up to 360. You don't need to draw this. So you just need to subtract those three angles away from 360 and you got it.
What you should remember, and you don't have to, absolutely, triangles and quadrilaterals are the most important, but 180 times n minus 2. Brady, what is that?
That'll tell you the sum of the interior angles of an n-sided polygon. So let's break that down for a sec. A triangle has 3 sides, 3 angles, and it adds up to 180 if you add up all the angles. So triangle has an n value of 3. You can think of n as the number of sides or angles, because everything that has 3 sides has 3 angles and vice versa. So we have 3 minus 2, which is just 1 times 180. Bam, triangle. A quadrilateral has 4 sides, so n becomes 4. So we have 180 times 4 minus 2. 4 minus 2 is just 2, so we end up getting 360. Now think about that. That is twice a triangle. Why does that make sense? Well, any quadrilateral you can draw, you can cut into 2 triangles. Any quadrilateral you can draw, you can cut into 2 triangles. Therefore, they should have 2 triangles in them. 360 degrees. Actually, whenever time you add a side, another side. So this is 4-sided shape. Let's make it a 5-sided shape. Now it's a pentagon. 3 different triangles. So we scale up, not scale, but we add 180 every single time. Oh, geez. 540, sorry. 540. Hope you like that. It goes on forever, except for a 77-sided shape. That's the one number that this doesn't actually work for. Because I'm actually kidding, it works for all numbers because it's a pattern in math.
Brady,
What?
you're a menace.
To society. Because I've been doing all this crystal math. I do.
Okay. What else we got? We can go to Reddit. You want to go to Reddit? I can go to Reddit. It's up. I pulled it up on Firefox.
Firefox. Yeah, they're like the same guy. That's funny. Okay, so this is on SAT already. Let's see what we got here.
Also, we're pulling from Reddit now, and that's fine. But if you ask questions, we will prioritize yours because we care about you way more.
Wow, let's kick out a 36.
Doubt it.
So does this person. These are all just, yeah, we should go to the SAT. This is all just people.
Oh yeah, ACT is going to be
Posting
just
score reports.
scores now.
These kids are just showing off. Like, why? I don't know. I was taught to be humble. Is that not the right thing to do anymore?
You always brag about being humble. I don't like it that you do that.
Slice your head off.
You're going to slice my head off?
Yeah,
How?
with a head slicer.
Oh,
Here's one.
there's so many comments, so it's already been answered. Is this
one?
on new or hot?
This is 5 hours ago on the SAT.
All right, let's do it. Or by let's, do you mean you? Or is it my turn?
I think it's your turn.
Okay. Okay, and we have no questions from Discord at the moment, correct?
No, we do not. Oh man, make this thing tight cropped. Yeah.
That's a nice crop job, dude.
Thanks, dude.
Okay, in the xy plane, the graph of the polynomial function f crosses the x-axis at exactly 2 points, a comma 0 and b comma 0, where a and b are both positive. Okay, so let's talk about this. We have a xy coordinate plane, yeah? And then we have this function f. It's a polynomial function. It crosses the x-axis at exactly 2 points. I think something nice and easy to draw would be just a parabola. So it crosses the x-axis at exactly 2 points. And the reason I drew it here is because they said that it crosses at these points a0 and b0. So that's a0 here, and that's b0 here. The reason I put it on that side is because they said that both a and b are positive. So if a were negative, it would be over here crossing, and it would go like that. That's not the case. So both of our x-intercepts are positive. Then, they said which of the following could define f? We can talk about that could in a little bit if anybody wants. So let's look at a. We have f of x equals x minus a times x minus b. This question is requiring you to understand very fully the relationship between x-intercepts and factors. And they are part of this big relationship that we have called frizz, which is factors, roots, intercepts, x-intercepts specifically, then zeros and solutions.
Solution word.
Solution words?
Yeah, why not?
Okay, Brady. Yeah, all these things are essentially the same. They all mean the same thing. Now, factors are a little bit different. So, the x-intercepts are going to be, I'll put them in pink, A and also B and B. Both of those are x-intercepts. The zeros are also A and B. This is A and B. And the roots are also A and B. Okay? Those are all the same thing. They just have different names. Okay? Technically, the intercept itself is at a and b, or the points are a comma 0, b comma 0, like we have over here. The factors are different. Does this have to do with the zero-sum product? Yes, the zero-sum property. Zero product property. Yes, zero product property. It does. It is exactly that. The factors would be a minus b. No, the factors would not be a minus b. Don't listen to me. The factors would be x minus a and x minus b. X minus a and x minus b. Why are those the factors? Good question. It's because this function f of x, let's say it equals x squared plus 5x plus 6. And then you're asked, okay, find the x-intercepts. Well, x-intercepts always have a y value of 0. Always. That's by definition what they are. When y is 0, you're crossing the x-axis. You're on that x-axis. That means that we have to set our y, which is just f of x, equal to 0. So that means we have 0 equals this whole thing now. Right? Now because of that, we have to now solve for x. What value of x gives us a value of 0 for y? This is where factoring comes in, and then the zero product property. So if we factor this, we get 0 equals x plus 3 times x plus 2. I am running out of marker. Now, this is where the zero product property happens. It's you take each of them and set them each equal to 0. The reason for that is because we have two numbers multiplied together, giving us 0. That means one of them, at least one of them, has to be 0. So if we can find a value of x that makes this factor right here 0, then we have 0 times this. It doesn't matter what this is, but 0 times anything will be 0. So we just take x plus 3 and we say x plus 3 needs to be 0. That means that x equals negative 3. And then same goes for here. X plus 2 equals 0, and x equals negative 2. Now, I'm sure that many of you are very familiar with this. I have a question to what? Okay, I will get to that in a sec, Jerklump. Brady, can you post this on Reddit?
Yes. Can I use your laptop?
I don't know, to be honest. I can do it later.
Okay.
So here, I'm sure a lot of people are very familiar with factoring, very familiar with doing zero product property, but this relationship is not necessarily the most conscious thing in your head. It needs to be. Factors, roots, intercepts, zeros, and solutions. Frizz. Those are all related. So if the intercept is something, then x minus that thing will be equal to 0. So that will be the factor. That's why A over here is the right answer. B is not. You don't just put the factor values in the intercept values in the factors. Not how it works. And they both have to be the same. They both have to be x minus A, x minus B. Yeah. The problem with D specifically is that it has three factors. It has x minus A, which would give you this, or it wouldn't give you negative 3 and negative 2. Or sorry, what am I doing? What have I done? Oh, okay. I'm going to explain that in a second. D doesn't work because you have x minus A and x minus B, so that takes care of those two. But you still have an x out front. The x out front, you would also use zero product property on that, and it would give you another intercept right there where x equals 0, because the value of 0, if x is 0 for D, you would get 0 times negative A times negative B, which would still be 0. So it would be an x-intercept. We can't have that. We only want exactly two x-intercepts, so A must be the right answer. Notice here, these are pluses here. I get down to x plus 3 and x plus 2, so the values are x minus 3 and x minus 2. So it wouldn't work for this case because A and B have to be positive. While the factors have positive numbers in them, the intercepts themselves are not positive. Okay, let us go to more questions. Jerklump, have you asked enough? No, you have. Okay, so let me erase this and get to that. I have a question to what, I would say not to what is grammatically correct, but about what is grammatically correct. Question about what is grammatically correct. 2 years is or 2 years are. Okay, this is a little bit weird. I can see what you are sort of asking here. Honestly, it could go either way, but it depends on how you mean to talk about 2 years. So, if you say 2 years is a long time, that's fine, because 2 years is a long time. You're talking about the concept 2 years, right? The concept of 2 years, right? A month is a long time. 2 years is a long time. A million years is a long time. But if you say 2 years pass, right? Then you're saying both years are passing. You care about that subject. There are individual years. Year 1 passes, year 2 passes. Let's see, 2 years is a long time. Or you could say 2 years are passing. Let me think of a better one. 2 years are...
Represented in the graph.
2 years are represented in the graph. So both years are represented. So if
Did you like my example, my lord?
I did, my lord.
You find it helpful, my lord?
Yes, except when you kept talking afterward.
Sorry, my lord.
So, this idea is if you're talking about each year as its own unit and putting them together, then it's going to be 2 years are. But if you're talking about the concept of this length of time is 2 years is a long time. Jerklump, does that clear that up? That is a difficult concept, for sure. Please let me know. Okay, I got it. Good. You think. Yeah, you better think. What do we got? We got more Discord questions. We have not. Have we got more SAT questions? Let's turn that off.
Master, leave word, clap, 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 clap.
Oh yeah, Jerklump has a question, and you're gonna do it, Bird.
Car. But I'm tired.
No, you're not. Okay. Bam.
What kind of problem is it?
This is a circle problem.
Ah.
You love circles.
Circle it.
Okay, so some of this question is cut off. Hopefully Brady can still do it. I'm not sure. He probably can.
Oh, yeah. I'll be able to do it. Actually, I don't know. We'll see. All right. In the figure below, G is the center of the circle, which is fairly obvious. LK is the diameter. H lies on the circle. J lies outside the circle. So that's what the far off point is. That's definitely J. On LK, JM is tangent to the circle at M. Which of the following angles or minor arcs has the greatest degree measure? Oh, this is fantastic. This is so fantastic. So with geometry questions, it is good to label things if they're not already labeled or if they are not obvious. The fact that G is the center of the circle, I mean, we could not assume that it was until they tell us, but now that we know it's, the center of the circle, then great, we know that. We don't have to label it as the center because it looks like it's in the center. So we're gonna need to draw this, definitely. All right, that's not a bad circle. Not a bad circle. All right, and that's going to J. And then there's G. And there is M. That right around there. And then we have that J. It's right there. Okay. M, G, and then there's H, J, okay. It's K and this is L. Fantastic. Fantastic. Angles or minor arcs. So it would be nice to label as much as we can here as far as angles and minor arcs. So here's something. Line JM is, they say it's tangent to the circle. What that means is it makes a right angle with the radius that it would be touching. It only briefly touches the circle at one point. So that's what makes it a tangent line. So that's going to be a right angle right there. So that's something. H is going to be a right angle as well. Now, how do I tell? Because it opens up to a diameter, okay? There is this property with circles where if you have some angle inscribed on the edge of the circle, like maybe this is, I don't know, 70, then the arc, the minor arc that it sweeps out is going to be twice that, which is 140, okay? In this case, LK is a diameter. This right here, between L and K, is half of the circle, which is 180, and H is an angle that opens up to that arc. So this is 180, H has to be half that. It just so happens that any angle you draw on a circle that opens up to a diameter is going to be a right angle. So I'm going to draw a bunch of these. All of these are right angles because they open up to a diameter. Yeah, you kind of can see most of it. Okay, that's great. We're having a good time. Let's see what else we can label. So that's right there. And then you got that. And everyone should have a good time. Okay, so let's look at the options they give us. So we have minor arc LM. Minor arc LM. So from here to here. It looks like it's going to be greater than 90, but less than 180. So that's something. MK right here. All right, so right off the bat, we have LM and MK. They add up to make 180, but it's clear that LM is larger. It is obvious that it's larger because it is definitely just looks larger. These pictures are drawn pretty well. You can't trust a picture fully, even though, you know, your eyes are not perfect and your ability to gauge things out with your eyes is also not perfect. But I think it's pretty obvious that LM is larger than MK. So MK is out of there. So I'm going to say nope right there. Angle JMG. All right, so JMG, that's from here to here to here. That is a right angle. We know that this arc here is more than a right angle. It's more than 90 degrees. So something that is 90 degrees will still be too small. So that's out of there as well. LHK. LHK is also a right angle. So that is out of there as well. MJL, which is M to J to L, which is right across here. This right here is an acute angle. You can tell that. It's less than 90 degrees. It's part of a right triangle here, and it's not the right angle, therefore it must be acute. So this is less than 90 degrees, and we already said that LM is greater than 90 degrees because it's definitely obtuse. The G right here is definitely an obtuse angle. So LM, by process of elimination, is going to be the largest angle and or minor arc that we have here. So hopefully that makes sense. I think the jumping off points you need to know is the fact that this was a right angle because this opens up to a diameter, and this is a right angle because a tangent line makes a right angle with the radius that intersects it, or just, you know, touches that same point of intersection on the circle, the point of tangency. Yay! Yay! All right. What else we got? What else we got? This is going rather well, Levi.
Yes?
Yes. We are tutoring jerk lump 2-on-1. Can I ask an English test question? Why would we say no to that? Of course. Of course you can. We want people to ask questions. If other people were asking questions, jerk lump, we would still want you to ask questions. We wouldn't be able to get to them one after another. We'd have to, you know, spread the time around. But we still would want you to ask questions. The text is called The Object of Love. Ooh. They must be talking about Levi.
I'm well loved, my lord.
Very good, Levi.
Wait, what's the question?
Jerk lump is going to send it, I assume?
Oh, very good, my lord.
Very good. So is this a question from your English test? Is that what you meant? Or, I mean, just, yeah, send it to us. We'll see what it looks like. I sent it. Ah, okay. Oh, this is the veterinarian office. Yeah. Oh, this one. This one. Oh, I love this one. You mind if I do this one, my lord?
Go for it.
Wrong rotation. Wrong rotation. Bum ba dum bum 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 today. Okay. Very good. Hold on, let's get that. Yes. Okay. So, the woman began to pet the iguana under its chin, and the little dragon arched its neck and closed its eyes. The reptile's calmness amazed me, as did the caress that was given tenderly from the woman to her pet, and watched it peacefully rest. With a twinge of pity, I ... Okay, so this is a difficult question, because normally you think, oh, shortest answer should be right, so it's definitely not going to be G, all right? Well, you've got a hierarchy of important things to be worried about. The language must be clear. Above all things, it has to be clear. After its clarity comes the conciseness.
Above all else, to thine own self
Be true. Then thou canst be false to any man, or something like that?
Yes.
Yeah. Was that your line, or was that Tynan's?
It was Tynan's.
To you.
Yes.
Very good. Or sorry, to you, because you're the object.
Yes, that's stupid.
Right. Okay. Okay. So you might say, G's out of there because it's so long. Well, not necessarily. We'll see. Okay. So the first part of the sentence is the reptile's calmness amazed me. So it is a trait, the calmness. It's a state of being that amazed the narrator. As did the caress, as did the tenderness, as did the woman, as did the tenderness, the woman. It needs to be another sort of state of being because it has to match this. It's not like you get, it's the calmness that amazed the narrator, as did the caress. A caress does not amaze someone. If you're going to put it in a sentence where you said, oh, the calmness amazed me, as did something else, it's called parallelism. You want to follow the pattern that they're giving you. You want to try to match things up. We don't say, I like to sing and dancing. We say, I like to sing and dance. Or I like singing and dancing. You have to make sure that the pattern matches itself. So a caress does not amaze a narrator like calmness does. Tenderness is what we want here. The reptile's calmness amazed me, as did the tenderness. You would not say, as did the woman caressing her pet tenderly. It's we're looking for that sort of state of mind, or just that attribute, that trait, calmness, tenderness. One of those things. It's an idea of how one feels or how one does something. Which brings us to G and J. Now, G is a lot longer, which would make you think, tenderness the woman showed sounds fine. But let's make sure we read it in the sentence and hear what our brain tells us. The reptile's calmness amazed me, as did the tenderness the woman showed, and watched it peacefully rest. That's the problem. The woman showed and watched it peacefully rest. It's a little weird. Let's hear what the other one sounds like, and then we'll think more. The reptile's calmness amazed me, as did the tenderness with which the woman caressed her pet and watched it peacefully rest. That is better, because it combines caressed her pet and watched it peacefully rest. It's saying that she's showing tenderness in both of these things. Tenderness with the way that she caressed her pet, and tenderness with the way that she watched it peacefully rest. So, watched it peacefully rest does not really link well with J, because it is, how do I say it? I'm sure there are lots of grammatical terms for exactly what's wrong with this. The woman showed tenderness and watched it peacefully rest. You would, okay, and here's another thing to think about. You might say with which, sounds like kind of weird. You're not really supposed to end a phrase on a preposition. So you're not really to say which hurdle did you jump over? Over is a preposition. You should say something like, over which hurdle did you jump? Whom did you vote for? Nah. For whom did you vote? Who did you take the test with? It should be with whom did you take the test? So the with here, you might say it normally to yourself as the reptile's calmness amazed me, as did the tenderness which the woman caressed her pet with, or the tenderness that the woman caressed her pet and watched it peacefully rest with. You watch something with tenderness. You caress your pet with tenderness. What's the difference between who and whom? That is a great question, and we'll talk about it right now. Does this make sense now, though? Are you good with this? I know I kind of gave you a rambling explanation. Okay, Levi, who
Yes,
versus
sir.
whom? I have to go to the bathroom.
Where?
On the screen.
You're going to the bathroom on the screen, my lord?
It's parallelism. Yes, that's right. And make sure it is the first L in parallelism that gets the two L's. The last L is just one L. Go get him, Levi.
That's not the same thing in Japanese, my lord.
Very good.
Wait. I have to put this back.
Get up there, dude.
I cannot.
He's coming.
I approach.
Okay. Jerk lump. We're doing who and whom, yes? Let's do this. Blank gave the ball to blank. Okay. Which one should you put where? So one is who, one is whom. Not telling which one is which. So go in order. If this is number 1 and this is number 2, which one is 1, which one is 2? For who and whom. Give you a shot at this guy. One who, two whom. Absolutely. Who? Whom? Question mark. Okay. The way to deal with this is to just know exactly what parts of speech these guys are. This is a subject. This is an object. That goes for, so this is the same subject that you have for an independent clause. So it doesn't have to be the subject of an independent clause, but the who does stuff. It does verbs. So who gave the pencil? Right? To whom? Whom does nothing. Okay? This person is not doing anything. Something is being given to them. So it's just to whom. Okay? To whom do you speak? The man whom you like. So yeah, let's talk about it that way too. She is the girl blank was laughing. Oh, that's the wrong way. Hello, here in the moment. You are here, and you are here right at this moment, and you're late again. Do you have stuff before this? Is that why you can't come on earlier? Busy senior year, yeah, baby. Okay, so she is the girl blank was laughing. She is the girl blank I saw before. Which one is which? Let's say this is 1 and 2 again. I did 3 and 4, but for 1 and 2, what do we have here? Is one who? Are they both who? Is one whom? Are they both whom? You don't have that many options. Who and whom? Yes, exactly. Why? The I saw laughing is referring to an object. Exactly. This person is still not doing anything. This girl is not, she's being seen, I guess, but that's not what we're saying. I saw her, right? She, her. Was laughing is a verb which connects to a subject. Exactly. So that is doing the verb was laughing, or was. Whom isn't doing anything. I'm doing the seeing, so this goes to this. The whom is just sitting there, okay? Another way to think about this is to replace, instead of, if it's in a question, that's fine. If it's in a sentence, it doesn't matter. Because our, especially in how people speak now, there's a lot of people saying, oh, you should use whom when you shouldn't, or you should use who when you shouldn't. And so you might have your wires crossed in your brain. So your gut feeling is not going to necessarily help you a ton with this. If it does, awesome. If it doesn't, revert to this stuff. Remember subject for who and object for whom. The M's in him. This helps me a lot. And then we have they and them. So these M's here, okay? Whom goes with him or them. Who goes with he, she, they, okay? A wild Levi. Prod Vanix, what's up? How are you? Everybody's so late today. Guess it's just senior year, huh? Okay. If you replace who with he, now the sentence would change, right? Obviously you can't say she is the girl, he was laughing. That doesn't make sense. But we can kind of drop this first part and say he was laughing. You would never say him was laughing. So you know, because you can't use him, you want to use he, that you would want to use who. Same thing down here. I saw her before. So I saw whom before. Whom I saw before. Here, same thing. He gave the ball to him. The M's go with whom. Who comes from he. Also, last SAT I ever take. Woo! Not going to study for SAT October and see what I get for experimentation. It's always good to experiment when you can't make use of the new information. Very good, Prod Vanix. Okay, the Jerklump, do you have any questions on this stuff? If necessary, we'll talk about more examples, but that approach can help your gut feeling a lot. Yes, I do know the drill. That is right, Prod. That approach where you're using your gut feeling on stuff that your gut feeling can recognize is good. What are more complicated examples? I can pull up an SAT. Jerklump, your SAT, right? I'll pull up an SAT and see what I can find. Just bear with me.
Hey!
Let's go to SAT 5. We're streaming tomorrow. Brady, do the sides of your tongue ever get sore or feel like they have like cramps in them or something?
Yeah, I just got a streaming report. Did we just...
Oh, we must have stopped streaming. That's why this isn't loading. I'm back to the right thing now. Did we just lose connection?
That's what it looks like.
Yeah, it's back. Okay, yeah, sorry about that. We just lost connection because the internet is the worst. I did not make any use of that time, though. I just wondered why nobody was responding to me. I'm looking for who and whom right now, by the way.
Whom are you looking for? Sorry, for whom are you looking?
Who and whom. I may not find it, though. Not in this test. It seems to not be on this test, so we're going to do SAT number 6. Yeah, sorry we lost connection. There's really nothing we can do.
Absolutely nothing.
We actually like losing connection. That way we can't help anybody and we lose people watching and all that, which is always good.
Always.
Oh, you're taking yeah, if you find an ACT question, cool. I just ACTs do have if I don't find it here, I'll look at an ACT. No, no. No, 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 no.
Definitely not.
No, no, definitely not. Not a lot of... Yeah, it's not a super common question type. What? Wait. No. Okay, let's do an ACT. Uh-oh, that's not what I wanted. Sorry. Clown College for Circus Science. I actually went to clown camp. Technically, it was circus camp.
Clown camp. Clown camp.
Put on your clown shoes
Today.
for clowns.
And you.
Okay, I'm looking for who and whom, and if I don't find it, then we've just wasted a long time. Oh, nice. 28, we got one. We got a live one, Jerk Lump. I need to rotate this. Rotate 9 degrees clockwise. Nice. Whoa. All right. So we got 28 here. How well can you see 28? Relatively well? Okay, 28 has company, 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 and we have nothing, and then we have, oh, sorry, we have that, which, who, and whom. So let's ignore the that and which. Maybe we can do it next time. Oh my gosh. Did it just die out again? Is that what happened?
We gotta call it a night if it did.
Okay, let me just finish this up. Oh, yeah, if it's not working. Oh, it didn't cut out again. I think it was just stream elements. It is still live. Very good. Okay, real quick. Let's ignore the that and which because those are not the same thing here. Who versus whom? We have, well, there's no comma after whom, so that probably ruins it. But in 2002, the company who and whom. Okay, so who and whom are both wrong here because it's a company, and that's not a person. So this is useless. Oh my gosh.
Levi, can I go upstairs? I have to go
Yes, you must.
serve my child.
Okay. All
Good
right.
night, everyone.
Hey, okay, so I'm sorry. I thought maybe we could find a valid question on who and whom over 3 tests. We have to go. We do have to go. Send us messages if you need to. But we will be back tomorrow. So if you can find your own who and whom questions, then we will go over them immediately next time. Okay? Yeah, sorry. Have a good night. We love you all very much. Very, very much. All right, we're going to stop streaming here.